right? So we need to find, okay, when you sort, so did you sort find by relation? Did you sort the array?
No, I just looped through it.
Okay, so okay, what you have done here, if you stop here at the find by name, so what you have done here is, let me see, this is find by name, right? So this is a selection sort. So you already sorted, and you already search even inside the print statement, which is fine, okay. And you have to do both of those, sorting and then binary search inside find by relation. And again, like I said, the trick that this binary search only return by one. And then when you search, when you sort, here you sorted by name. But if you want to find by relation, then you have to actually sort by the relation that is required here. You cannot sort by name anymore.
Yes.
So do you got my point?
Yes.
So just now only, I would like you to only do the selection sort by relation, and then you can proceed to do this binary search as a homework, and then maybe I can check it tomorrow. Okay?
Okay.
So just do this selection sort instead of by name, by relation.
Okay.
I think it should be easy, right?
Yes.
But may I understand from you one thing? Why do you think we ever do this sorting and binary search? Why we use, I mean, if you can do a loop and you can search a list for something, why we need to bother ourselves doing the binary search? Do you know why we need to do binary search?
Well,
In the
main
first
reason is that binary searches tend to be more efficient, so it takes up less than just like a normal for loop.
Okay, so good. That's for the exam. Okay, good. So try to sort and print out what you have sorted so that we are able to see. Yeah. Is it sorted?
By alphabetical order. Almost. There's a few here that's not sorted.
Okay.
Oh,
so,
it is. Actually, it is. Sorry, I read it wrong because this was just a find. So yeah, it is sorted.
let me see. Yep. Okay. It's sorted. Yeah. Okay. So it means you are a smart boy, and I would say your binary search will depend on your how strong your observation is. You can see that. So if we manage to find the first friend, it means that there might be a way that we can continue searching until we find all the friends. So because they are sorted, right?
Yes.
Okay. So tomorrow you do it. Okay.
Yep. Yes.
Okay. Okay. Good. And show me your find by name, please. did you do the function? I think you have done the function. Let me check it again, please.
Yes.
Find by name. Yes. Okay, you have done it. Okay, good, excellent. Let me then share with you. Did you? I think you already studied and completed this topic 7 control, right?
Yes.
Okay. And but you still, like you told me, the most difficult portion was this networks and abstract data types, right?
Yes.
Okay. How is recursion?
It was fine, at least in my opinion.
Mm-hmm. Okay. So let me share a few things with you, and we will go to the abstract data type at the moment. But so this is an exam question that is related to control systems. So he's telling, I just want to understand how far you are in the control systems. We will not go into too much details on that at the moment, but just let me try to understand what your status at the moment. So smart control system can manage the temperature within a house. Outlines the steps involving the sensor, processor, output transducer to manage the temperature in the house. Do you mind if you just tell me first, what is the sensor, what is the processor, what is the transducer?
Well, a sensor is a device that is able to measure certain parameters.
Okay. And what is the input and output of a sensor?
Well, an input is typically an analog signal and involves parameters such as temperature or proximity or brightness.
Excellent. And what is the output?
The output, uh, well, the output generally comes in the form of an analog signal that's then converted to digital through DAC.
Okay. I this needs some correction, but okay. The processor. But again, I mean, it's just like we are not. I'm not testing you, as you know. I mean, I just want to know where I can fit my hand and close the gaps. That's what I'm only doing. I'm not. This is not testing, and nothing goes out from this class to be reported to anywhere. This is between me and you. I just know where to close the gaps. That's it. So don't think that I'm testing. Yes, of course, I am triggering on mine. That's it. So please continue. What is a processor?
A processor is the part of a device, part of a computer that does the calculations required and like
And
execute tasks. Yes.
okay, and if we involve it in a control system, how it help us, and or what is the role that it takes in a control system?
Within a control system, processors typically take the input that's given by a sensor and then make use of it to give output signals to change things accordingly.
Okay, uh, does the processor can execute programs like Java in our case, if it is in a control system?
Uh, Likely not, because processors are within like control systems would probably be specialized, and so there would be no need to make use of like a high level language like that.
Okay, uh, okay. That what was you taught in the class, or that is an opinion of yours?
Both, I guess, because that part of information I didn't get specifically from like this unit, but like just information in regards to specialization I learned, and then I just like repeated it here because it seemed
Okay.
like it would make sense.
Um, previously your information was actually true, but recently specialized system like control systems come up with a processor that is actually able to run Java and even Python. But so yes, it is possible, and even the processor in a control system, some of them are loaded with a lightweight operating system, a specialized operating system. Same, okay, like let me give you an example. So a phone, an Android phone is actually a lightweight operating system. It's not a heavy duty operating system like the Windows. It's just a lightweight that can fit through the limited memory that is available for the processor for the phone, and still can work. So we still can consider a phone like a control system. And it takes a lightweight operating system, a specialized, customized operating system. Does this make sense?
Yes.
Do you know what language? Let me understand. What do you have for your IA?
Like
The
the
project.
language or
No, I mean the project that you're having for your. Typically, you have a project, right?
yes.
Okay. Is it you started working on your project?
Pardon, the audio cut out for a bit.
Okay. So no, I was just asking you. Did you start working on your project?
Oh, I already finished the IA.
Haha. Okay. Good. Okay. And what was your project then?
It was like it was a program to like keep track of tasks and such.
Haha. Interesting. And you have done it in Java.
Yes, in Java.
And you have done a UI on desktop or mobile.
On desktop.
Okay, excellent. And what kind of library did you use for the UI? You know what the meaning UI?
Yeah, so for the UI, I think I used the swing. Is that what it's
Okay.
called? Yes.
Yes. Okay, excellent, Leo. Okay, so yeah. Okay, and then what is then the role of the output transducer?
Well, an output transducer would take like electrical signals and convert it into like another form.
But this is an output transducer, not only a transducer. So what do you think it will take then? So an output transducer, where it is located in the control system. So is it before the processor or after the processor?
Or after the processor.
Okay, and before the DAC or after the DAC?
The deck?
Okay, so we have ADC
Yes.
and we have DAC.
Oh yeah.
So your output transducer is located here or here.
It would be after because it's like the last
Smart.
part.
Yeah, okay, good. And this output transducer, what it will do, so if we are operating in the temperature inside the house, so what can it be its role in cooling or heating the house?
Well, it would be the part that like actually does like the cooling or heating, right?
Yep, but so it means that it will trigger somehow the heater or the cooler to cool or heat the house. Am I right?
Yes.
Okay, and then what is the role of the feedback in the control system? Do you know what is the feedback, right? You,
Yes.
okay, so that is how it looks like, or is it correct or wrong?
Yeah, that's correct.
Okay, and then what is the role? Why we need to use a feedback? And if we use an open loop system, what would be the issue? So just tell me first the role of the feedback. Why is it important?
Oh, well, if we're talking about situations for systems where you need to be like constantly adjusting something based, like where you have to be constantly adjusting something, like the temperature example before, you'd have to be constantly taking the input that's changed based on the output in order to like adjust it accordingly.
Can you repeat again or rephrase it again, please?
Oh, so if we're going by the temperature example before,
So, okay,
then
let me see. So I measure the input 50 degrees centigrade, and then you output something, okay? You output, for example, the cooler or the air condition, for example. Okay, and then the temperature become, let's say, 15. So what is the role of the feedback here and what it will do?
well, what the feedback does here is then it takes as input the new temperature, and then the processor would compare that to the target temperature that was set, and then use that as output.
Okay, so that's one thing. And so if we don't use a closed loop, what will happen? So if in this specific case, we have a control system inside the house for controlling the temperature, and I don't have feedback loop, what will happen?
In this case, if you don't have a feedback loop, then there would be no way to like continually adjust the temperature based on the target. So after just like adjusting it once, there would be no way to change it again.
Okay, and so if we adjusted the temperature, now the temperature is 50, and then we instructed the processor took this and compared it to the preset temperature, and then he output something to cool down and reduce the temperature, but we still see that the temperature still go up a bit. So what do you think we should be able to do with the feedback? Should we continue to operate the air condition on the same way, or we need to do some adjustment, maybe to increase the amount of cooling, or what should we do? Because the air condition is something that you operate on and off, right? But then,
Yes.
okay, and so typically, if you have an output like that, you will use an air condition that you are able only to set on and off, or you would use something that can accept an analog signal out of your processor or out of your DAC.
Yes.
And yes, you will use something that can accept out analog signal.
Yeah, I think so.
Okay, yes, you are correct. You guessed that correct, actually. Okay. So typically the feedback system, actually what it does is that it always monitors the difference between the input and the output. So, and it subtracts them and come up with something called error. And based on the error, it feeds it back to the processor so that it can fine adjust the output. Okay, so the error is actually what is fed back here in this loop. Okay, so of
Yes.
course I can see that in your syllabus they don't mention too much details, but okay, I would like to only share with you a few things here. So I think now you can see this is the whole system. Forget about what I'm explaining above here, just look below here. I mean, from this portion. So, okay, now we have an analog input that come from a sensor, most probably. And this could be the output. and this is the processor. You told me the processor. Okay, so now first, you already know the function of ADC and DAC, right?
Yes.
Okay, and you know their position is correct here. This is fine in your mind, right?
Yep.
Okay. You told me before that we use a transducer here. Why do you think we need to use a transducer in the output and possibly even in the input?
Well, because a transducer is what like converts the electrical signal to other forms of energy, right? So
Okay, okay, that's good. Let me see. And what is actuator?
I'm not sure.
Okay, so an actuator actually can be, for example, a pump. No, the actuator is, yeah, you can say it's like a pump, and we would say that the output signal can control, if we put a transducer before the actuator, somewhere here, so that will take from the DAC and convert that to an analog signal somehow. And once it go to the transducer, then it will convert that to electrical signal, and that will be transferred to understood by the actuator so that it can vary its output. So let me see. If we want to operate a heater, and the heater system looks like this in the case of house, okay, and we are operating a pump, a circulation pump. So we are able to control the speed of the pump in a way based on our output that we are taking out from the DSC and the transducer. So if we want to really heat up the place, it's cold and it's winter, we want to heat up the house, so we will make the pump work with a slightly higher speed so that it can push the hot water all over the radiant places, the radiant system all over the house. So we have radiant heater in many places in the house. We heat up the water, and then using the circulation pump and the speed that we control the flow, its flow with our DAC, then we are pushing the water either faster or slower. If we are pushing the water faster, it means that we will be able to heat the house in a less amount of time. Does this make sense to you?
Yes.
So if the temperature is so cold, so might be we need to operate the circulation pump to the maximum. So it means that we have to give a high analog signal. Does this make sense to you?
Yes.
Okay, good. Let me see how else I can close the gap here. Okay, so a transducer, some of the forms that actually share with are shared is actually that the transducer is actually a part of, is a sensor plus signal conditioning. So to convert an energy from one form to another, we actually use a transducer, and it's not only used for electrical signals. So like an example for a transducer actually is a microphone. So microphone converts sound waves to electrical signals. And also a speaker can act as a transducer, but it is used on output. So it converts electrical signals to sound waves. Does this make sense?
Yes.
Okay, good. So let me share with you also the difference here. See here. So do you know the difference between a normal temperature sensor and a thermocouple?
Not exactly, I guess.
Okay, so a short difference between both of them is actually, let's see here. So if we look here at the sensor, so a type of sensor that we are able to use from temperature sensor is that thermistor, an RTD. But thermocouple is actually a transducer. So the thermocouple it measures the difference in the temperature. The difference in the temperature, not only the temperature, but just the difference in the temperature. So that's why we consider the thermocouple as a transducer, not a sensor. So again, temperature sensor, there is two types here, thermistor and RTD. But a thermocouple actually as a transducer. It measures temperature, but it measures the difference in temperature. Okay, and this is how the transducer would look like, and this is how a sensor would look like. Okay.
Yes.
Okay, good. Let me then. Do you understand what you're seeing in the screen at the moment, especially for the actuator? Forget about the sensor. You already know the sensor.
Yeah.
Okay. Let me also share with you another example of actuators. Let me see if I have. Unfortunately, I think I deleted it from here. I think you can see it from here. Leo, we have to close and open again, please.
Yep.